and we look at risk calculation. We say that the maintenance function has a high influence on organizational risk. The maintenance function typically inherits a certain risk profile from the engineering or the design function. In other words, you have equipment that has been designed in a certain way, and thus you have a certain risk profile involved. It then has to manage that profile based on the constraints that the production function poses through their operational practices. We say this is mostly a non-enviable position with a high opportunity for blame shifting to the maintenance function. In other words, a lot of blame shifting takes place to the maintenance function because of that. Because you sit with a risk profile that you inherited, and you sit with the production function that practice their operational or performs operational practices in a certain way. And whenever something goes wrong, there's only one that can be wrong, and that's the maintenance function. So it's a non-enviable position. But okay, that as introduction then. In terms of then calculating the risk, we say, well, there's the definition of risk. Definition of risk is that risk is a probability of occurrence of some risk factor times the consequence of the occurrence of that risk factor, and that then gives you the risk that is attributed to that risk factor. Risk, or we call it the risk consequence factor. Now the factors involved in the maintenance case are these. So we identify 5 risk factors, risk consequence factors: safety, lost production, lost quality, environmental effects, and maintenance cost, money figures. And then if we now calculate the risk for each of these factors, then being the probability of occurrence of that factor times the consequence of if it occurs, and then added together the 5 risk factors, then we get that gives you the compound risk, maintenance risk. Total risk for the plant and equipment is calculated from that equation. And now, if you have such a risk figure, you can then plot the risk of different pieces of equipment. Or so this could be used to calculate the risk for a certain piece of equipment, or it can even be used to calculate for the various failure modes of a specific piece of equipment. But more typically, one look at the risk for a specific piece of equipment. And then you can compare that against other pieces of equipment by plotting it on a set of axes where you have consequence on the one axis and probability of occurrence on the other axis. So you can plot it like that. And then it makes sense to construct some ISO risk lines, so that the different points are more easy it's more easy to compare different risks against one another if you have ISO risk lines. So if I plot a risk and I plot that risk there, let's say I have a risk that sits there and I have another risk that sits here. If I don't have the ISO risk lines, then I won't know how that risk compares to that risk. But if I have the ISO risk lines, I can see that this risk is amongst the second to third ISO risk line, whereas this one is between the fourth and the fifth ISO risk line. So this risk is much higher than that risk there. So that's the use of the ISO risk lines. You can work without it, but in the risk world, people tend to draw these ISO risk lines. So in this case, it is we have a risk profile that says a risk of 40. Now let's say that's 40 million, for instance. That means that any point on this risk line represents a risk of 40 million, let's say, rand. So, whereas any point on this risk line will represent 20 million. This will be 10, that 5 million, and that 1 million randoms. So that's the idea with the ISO risk line. So you draw the ISO risk lines and then you plot your risks in between them. Okay. But as I say, you can work without that. And then of course we can say that the risk increases in that direction. Increases in that direction. We typically get something like this. So here we now have different risks that we have plotted, and in this case the idea is that that larger star is the average risk of the whole situation. So one could also do that. You could also calculate the average risk and also plot that. So if you now have different let's say this is a specific piece of equipment, and these are the major units of the piece of equipment. So you have the risks of the various units on the piece of equipment, but there you have the average risk of the equipment itself. And now you have similar graphs for other pieces of equipment, and then you can compare them against one another, and you can then decide, the idea then being that the ones with the highest risks you address first, so as to try and improve the risk profile. So that's the idea. That's the idea. So you don't just calculate the risk, you calculate the risk with the purpose of improving. It's a wonderful macro tool, this. Wonderful macro tool. One of the best. Something else that you can do is you can also draw lines like this. Of course, you have to decide yourself what these levels are. But if you draw lines like this, you can identify risks that are chronic. In other words, that occurs too often, where the probability of occurrence is very high. Those are chronic risks. And risks that have a very high consequence, you can call acute. Okay. So as to manage them. So now you have 4 quadrants of risks, and you can manage your risks better that way. Necessarily, the ones that are both chronic and acute are the ones that you would like to do something about fastest. The second group that would be these ones that has a high consequence, but not such a high probability of occurrence. Third ones would be this and then that last. Okay, so that's the idea. Why do we say that these are more important than these? Simply because risks with a high consequence but a lower probability of occurrence is worse to the organization, because if they occur, they have a high impact, and you don't always know when they're going to occur because they have a low probability of occurrence. So they tend to surprise you. Whereas these ones that have a high probability of occurrence, because there's a lot of statistics about them, you can expect them, you know how often they happen. And of course they also have a lower consequence if they even have. But the fact is that you can manage them better. So what do we do? If we have a risk situation, how do we try to decrease the risk? The pound seeds is if you can do this. If you can reduce both the consequence and the probability of occurrence, that is the best situation that you can be in. The second most one that you would like to go for is this one here. See. as we said just now, your consequence is more critical than your probability of occurrence. And then the last one that you will contemplate is that one there. So what do we say? What are the ways to reduce risks? We say there are two components in an integrated risk reduction effort. Firstly, one can generally reduce your risk through a proper maintenance management practice. That's what we've been talking about the whole time this morning. When we talked about strategy and so on, putting in place that outer cycle and your structures and your things. That is the good thing to do for your business so that you reduce your risk of the whole maintenance organization. We talk about general risk reduction. So that is the first thing to do. We say this is affected by putting in place the following managerial structure items: maintenance policy, procedures, business plan, processes, maintenance plan, maintenance administration principles and procedures, maintenance systems. In other words, that the organization works like a clockwork, that it is a properly run organization. That's general risk reduction. And then also development of the maintenance workforce. The workforce is developed in terms of knowledge, in terms of procedures, in terms of teamwork. And then going for management excellence that we just looked at in terms of chapter 13 of the textbook. This is achieved through a planned and concerted effort in applying good maintenance practice over a wide front in the organization. Now that's the first component. The second component is specific risk reduction through managing the risk of single high-risk items downward. The type of things that we just looked at in terms of the calculation of risk. This is an important facet of overall risk reduction. We say that risks do not appear by themselves, but through a concerted effort in reducing the risk of each major risk contributor. It is through these one-by-one risk reduction efforts that most of the benefits of having proper policies, procedures, and plans accrue. So we have an example, just an example calculation. We have a continuous miner, underground machine that cuts coal underground. Some of you might know a continuous miner. See, I see smiles. Okay, so we have one like that, and this continuous miner has a boom in the front, and it has a drum that cuts coal in the front, and then it has a conveyor as it cuts. It drops down the coal, and then at the bottom it has arms that gather the coal or whatever, and then it has a conveyor that draws the coal across the machine, and at the back you have a transporter, and it dumps the coal into the transporter. Okay. So the idea is this cutting head, this thing that turns and that cuts the coal, this thing has a gearbox. Normally inside this thing, it has this gearbox, and we are looking at that gearbox. We're looking at the life of that gearbox. We say it's 3 years. If it breaks down, it takes 6 hours typically to change this unit with another one. The cutting rate of this cutting head is 900 tons per hour. That's what you lose when it breaks down. The coal has a production value of 250 Rand per ton. The cost of the overall of that unit is 500,000 Rand, and you have 10 continuous miners in your mine or in your section, whatever. So, what we then do is we then, there's the information that we just listed. So we now calculate the consequence of the failure. We say it's the consequence of an overall plus the consequence of a production loss. Because when it fails, it is sent out for overall. And we say that that costs 500,000 that we set there. And we say that we also lose production. We lose 6 hours at 900 tons per hour at 250 rand per ton. So that gives us this loss. It occurs one time every 3 years. So we have 10 overalls for the fleet every 3 years. So we modify the method somewhat. So we look at not only the one machine, but at 10 machines. So we now not only have a one in 3 years units that can fail, but we have 10 times that can fail per year. So we have 3.33 overalls per year, whereas for one unit it would have been 0.33 for one continuous mine. The risk, we say, is then the consequence times the occurrence. That times 3.33 per year, so that gives you 6 million rand per year. That's your risk. That's your risk that you have to look at. And we can plot that risk then. And we plot that risk here on ISO risk lines. You see that our scale here now is not probability of occurrence, but occurrence number per year. So we have 3.33 per year, 1.85 million, and that is our position. And now we can plot all our other components of that continuous miner on the graph and eventually make decisions. Okay, so that's the idea. So we then say that, how do we now use that? After we've calculated, using risk to set maintenance strategy, we say, download the document Risk Signatures by Peter Buckland. That's one of the guys that's quite a leader in the Australian, in Australia, in the Asset Management, the Institute of Asset Management, or whatever it is called. I'm a member and now I can't even remember what's the name of that. Study the document. It suggests the link between the risk profile and the applied maintenance strategy. It's a good document there. It's really a good document. You have to download it because you can expect an examination question on that. And I'm not saying that now, I'm saying it because last year we had a question like that. So I'm not saying that it will be there again. The examination paper has not been set, but the fact is that I believe that is to be very important. Evaluate the document critically with the objective to use it as additional input to the strategy setting process. Note the axis has been switched and he uses failure rate, which is failures per year, which is the same as our number of occurrences per year. So his terminology is somewhat different, but the ideas are very much the same. Very much the same. So I think it's important that you do that.